Welcome to your first machine learning project. We're going to go over simple linear regression in Python. So while you should watch the entire video, you'll be able to explain what simple linear regression is, how it works, and why it's so important to machine learning. You'll apply your skills by building and using a predictive model. You'll be ready for the next project since there's important concepts we weren't able to cover all at once. And it'll be fun, seriously. Now what you need to do first, I need you to like the video, please. Like the video, subscribe to the channel, and ring the notification bell so you don't miss out on what's coming, because we couldn't cover all the concepts in this video. We covered a lot, but there's much more to come, so you're going to want to subscribe and ring the bell so you know when the next part comes out, and for other videos on the channel. Now grab a drink and a snack, sit back, and enjoy. It's going to be fun. Alright, I'll see you in there. Okay, hi everybody. So just to get you excited about what we're going to build, we're going to make this graph, and it's not just a graph. We actually have this red function whose job is to, given some age value, it can predict the height of a person. Okay, and we're assuming there's a linear relationship between these things, and that's what the data shows. And so we will make a linear model to predict the height given the age. Okay, so that's the red line. The blue dots are what was used to train that model, and we're also going to show what happens first if you have an untrained model. Maybe we have randomized this line, and so it's way off of the data. Okay, so let's get started. The first thing we do is Google search Google Colab. So we search that, click on the first result. We're going to make a new notebook, and I'm going to change the title of it to your first ML for machine learning project. And we're doing simple linear regression. Okay, that's what that graph was, is simple because it has one predictor variable, this age, to do a linear regression. Okay, and regression means in this range, it's going to predict values in this range. Okay, so we're going to make that title. And now what this Google Colab thing is just a interactive environment for Python. And so we can put code here, and we can also put text here. So if I was to put text, maybe I'd say this is our project. So I type it in there with my keyboard, and then if I hold shift and click enter, then it actually submits what we wrote. And same thing if we had code. So this is Python code. I can type in maybe print hi. Okay, and I pass quotes because it's a string, and then I shift enter to run that cell, and it runs this code, puts it in the environment, and it produces the output here, which is hi. And in fact, what it actually does is it outputs by default the first thing that is actually returnable. So this string will output itself as well. Okay, and that's useful if we have something like a is equal to hi, and then we could just write a rather than print a. Okay, so with that introduction, let's actually get started on the real stuff. So I'm going to put some text here, and I'm going to write get the data. This is our steps. Okay, here are our main steps. The first thing is get the data. So get our information, whatever we're going to be working with. So we saw from earlier, it's probably going to be these ages and these heights. Okay, and after that, our next step is to visualize the data. Okay, we want to see what's going on before we make our model. We want to figure out what we're dealing with, what kind of values, what are the values, maybe some summary statistics like an average over them, maybe some graphs like histograms to show frequencies of values. So we want to understand the data or visualize it. Okay, more text. The next step is to actually build our model. So that line, that function, build the model and train it. Okay, that's the really exciting one, is we're actually making the model. So we're saying what the model is, and we're going to train that model on the data that we have. And then after that, some people might stop here in the tutorial, but there's a very important extra next step to understand, is that this doesn't do anything. Like most of the time when you build a model and you train it, that doesn't really do anything yet. The point is to use the model, as in make some predictions on unseen data. Okay, so unseen meaning that wasn't what the model used to train on. Okay, so we trained it on this data that we're given, and then we're going to say, okay, in the real world, we actually want to use this model. We're trying to memorize or figure out this relationship between the age and the height, so that given some age, we can actually predict the height. Okay, that's what we'd use in the real world. All right, so with that being said, let's actually get on the first step. So luckily I made getting the data very easy. So there's a trick you can do in these notebooks to download information. And what we can do is exclamation, which basically means don't run Python code, but run like operating system command line code. It's the computer telling it to do something. And I have this link that's going to be in the description of the video. Copied it in there in a string. Okay, and we actually don't need the string, I don't think, but it doesn't hurt. So we do exclamation, which basically says tell the operating system to do something. wget, which basically means download and put here. And we have this link that it goes to. Okay, so when I run this, and you can also click here or shift enter. So you see it does this, it says it saved it. Where did it put it? Well, yes, I have this thing over here. So the files on the Colab, if you click refresh, or maybe it'll show up automatically, it has the name of this file right here. And don't get confused by this .pickle, and yes, it's funny that it's called a pickle. It's just a file that we can use to open in a way that makes it really easy to look at. And if you're more familiar with CSVs, comma separated values, this actually happens to be a lot easier in my perspective, the data the way that we're going to. And we're going to use a library called pandas, which is extremely popular. And if you want an introduction that's better than this one for using pandas as well as NumPy and Matplotlib, we'll see pandas in Matplotlib. We're probably not going to see NumPy in this lecture, but I'll throw up a video in case you want to see like an hour of getting used to those three libraries, which are extremely important. But for now, I'm just going to go ahead and use them. Import pandas as PD, and its job is really for looking and messing around with tabular data. And I'm just telling you right now that in this pickle file, it is tabular data. So I can open it as follows. If we do pandas.read pickle, and we pass the name of the file, look what we get. Okay, so we output this thing, and I'm going to zoom out a little bit. Here we have the data frame, that's what this is called, a pandas data frame, which is essentially rows and columns, where we have these columns. So we have a bunch of ages and we have a bunch of heights. Now if you're confused why the ages are in like a floating or decimal point, it's just saying like, you're 14 and 14.7 age, and so you're very close to 15, and height is in inches. Okay, so age is in years and height is in inches. All right, so now that we've loaded the data, we just read pickle into this thing. I'm going to set this as a variable so we can keep track of this thing, and I'll call it raw data. It's just we've done nothing to the data. If I set that equal to this thing, then we have this in a data frame. And as I showed you before, we could output it like this. Okay, and that should be exactly the same thing. All right, so now what we want to do is visualize the data. And you could argue that this first step actually is kind of the most important, visualizing the data, is it's outputting some of the rows. So you'll see it says that it has 100 rows by 2 columns. We don't see 100 rows, although we see 100 of these like index values. That's because pandas by default is not going to show you everything, because it's just giving you a feel of what's in there. Okay, so to get a better feel of what's in there, we can do a couple things that are built in. If we have this object called raw data, we can call rawdata.hist. And what that does is produces a histogram for each of the columns. Okay, so this is just for the age column, and this is just for the height column. And what a histogram is basically a frequency count storing into bins. And what I mean by that is the x-axis is going to be the age value, and the y-axis is how many, for the data set, how many of these items have this particular age. So for example, around close to 0, we're going to have about 13 of those those rows. So there's 100 total. And around 10, we have about 9 people with age 10. We have about 10 people with age 14 or so, and so on. Okay, and so with the heights, we can look at that too. And we have, say, 9 people with a height of about 35 inches. We have many people with a height of about 30 inches. And we have less people with the height of around 60, 70 inches. Okay, so we're just getting a feel of the distribution of the data, how it's spread out. Okay, other things that may be of interest, we actually don't really use them too much here, but you might want to find out the averages or minimum and maximum values of this thing. It's always good just to get a feel for it in case you see something wonky. I'm telling you right now, you're not going to see anything weird in my data set because I just prepared this for you and there's nothing wrong with it. But it's really good practice, and later in the series, we're going to run into issues where you're going to need to look at this and sort out some problems. So let's just, as a good habit, we can do the following. We get raw data dot describe. That's going to give us some interesting information about each of the variables in our data set, aka the age and the height. Okay, so we have 100 of each of them. That makes sense. You can see up here we have 100 of each. We have an average of 8 years for age and an average of 46 inches for height, a standard deviation, so there's some sort of variation amongst the data. And we have a negative age. Okay, so this is why we do this, because, and yes, I did this on purpose, don't trust whoever gave you the data. Anyone, whether it's your boss or your coworker or your project partner or some person that published a paper on the internet like Google, do not trust their data. Make sense of it every single time by doing stuff like this, because you'll find that there's little problems with it that you would have missed if you didn't get summary statistics or taken a closer look at it in whatever way. Okay, so this is the fastest way to find something like this a lot of the time, is just to get a summary over the whole data, and maybe you'll find something like this that pops out, like a minimum or a maximum that makes no sense, or an average that is like way bigger than most of the data points. You'll see some interesting things. Okay, so clearly we have to actually do something with this data set. Not worry about that quite yet. Okay, so we have an average height of a minimum height of 27 inches, the 25th percentile, meaning 25% of the data has an age less than 3, and 25% of the data has a height less than 36, and the 50th percentile, otherwise known as the median value, means that 50% of the data has an age less than about 8, 50% of the data has an age greater than 8 as well. Okay, so the 50th percentile, it's right in the middle. And you could say something similar for height, and 75th percentile, and the maximum value is an age of about 18 and a height of 68 inches. Those both make sense. So now that we've looked at the data and we figured out we couldn't trust whoever told us the data was right, because it's never right, let's actually fix the data first. So actually, let me write here is a new step that we should always have in there, which is data cleaning. And that'll happen around the same time as data visualization or maybe building the model, because that's when we're actually looking at the data and trying to do something with it. Okay, so data cleaning means, okay, let's prepare it in a way that we can actually use it. And right now, it doesn't make any sense to have ages that are less than 0, because, I mean, you could have a weird interpretation of that, but it doesn't really mean anything. So let me show you something quickly where we can actually remove all of the information, all of the rows of the data that have an age less than 0. And you might not always want to remove the data. There's other ways of cleaning, but right now it's something much easier to do is just to get rid of that information, because I see no reason it should be in there. Okay, so if we have raw data sub age, okay, if I give it this notation, I do square brackets then pass it a string, that is going to get what's called as a series, or basically one column of information. It gets the age column. So if I just output that for you, it's going to be these same values that are up here, but just the age column. Okay? And now something cool I can do is I can do a comparison here. If I do this thing less than 0, then it gives me the same series, but with a bunch of different either true or falses. And I know you only see falses because most of them, most of the ages are positive. If I do something like the age is less than about what the average was, then we'll see some of each. Okay, so here, that makes sense. This also makes sense, it's just we can't really see it. So something interesting that we can do with this is we can basically reference the rows of the whole data set by passing this thing. Okay, so remember, this thing inside is nothing more than this thing we're looking at right here, these true and falses in a series. But if you put that in the square brackets like this, it is going to produce this same data frame, but all of the stuff that is less than 0. And of course, we don't want the stuff that's less than 0, but we want the stuff that's greater than 0. And so this is the information that we really want to keep. Okay, so this automatically will basically discard the other information. So we just need to store this in a variable. Okay, so we'll say cleaned data is equal to raw data, where the raw data sub the age is greater than 0. And then again, if I output this, it should be exactly the same thing we're looking at. All right, so we cleaned it. We think, again, run this yet again. I want to write clean data dot describe. So tell me what it looks like now. Okay, so we lost 7 rows. That makes sense. We saw that. Our age average went up a bit. That makes sense. The height average is now also went up a bit. That also makes sense. And other than that, it looks Other than that, it looks okay. All right. So we have a minimum of this very young baby and a very small height. He's only like 2 feet tall, or he or she's only 2 feet tall. And we have these values that all make sense. Okay, so we cleaned the data. Very important step that you might miss, but you need it. Now that we have cleaned the data, so I'm really going to change this and say, really we're visualizing the cleaned data. Okay, and you could obviously argue that above we did this too. It's fine, I'm just going to put this label here. And we're going to make the same graphs we did before, where we have cleanData.hist. If we call that, it produces our histogram for each. And we'll notice something if we look very closely, there is a difference here. If we look at the 0 age, notice that the values are strictly greater than 0. And above here, which I didn't even notice before, is less than 0. Okay, so we made that fix. Now, a more useful way to visualize this information, at least in terms of solving our problem, if we go back to our end goal, we have this data plotted. Okay, so we're looking at this paired data, and of course it's very important to, when you first get the data set, to look at these distributions all by themselves, just to get a feel of how by themselves what they're up to, and we'll see errors in the data that way. It's very important as well to, if this is paired data, we're going to plot this in what's called a scatter plot. So we're going to get the blue stuff now, okay, where we have the age in the years and the height in the inches, and we're going to plot this information. Okay, so to do that, we're going to use a library called matplotlib. Okay, and if you notice actually up here in the output, it's actually showing that pandas under the hood is really just using matplotlib as well. Okay, and the way to call this is matplotlib.pyplot as PLT. Colab already kind of knows that, at least it does for me. And it's very, very simple. We have this PLT object, which we're going to call almost every time. And if we write, if we write scatter, okay, so if we want to do a scatter plot, then what we're passing to this thing is x and y, so the x-axis and the y-axis, both being series of values, okay? So we're going to pass the ages and the heights except I want to define that first. So what we're passing is the ages is the age column of the clean data. Okay, so we want to give it these values. Okay, so let ages equal to the cleaned data of the age. Okay, so that column, and we want the heights to be the cleaned data of the height. And now we're going to scatter with the ages and the heights, and I'll show you what that does right away. There we go. Okay, so here's part of our graph, but if we look over here, we do have like a title, we're missing axes, it doesn't look that good. So one thing we can do right away is first pass a label. Okay, so if we pass the label object or label parameter to this function, let's call it raw data. All right, and then what we have to do to make that work, we actually have to make this thing run as plt.legend. All right, so that fixes this problem where we're not really saying what this data is. We're saying the blue is the raw data. Not really necessary quite yet because we only have one color, but it's good to have that there what the color represents. And now we need a title and x-axis and y-axis. And to do that, we're going to just call one function each on this plt object, and it's going to be plt.title, and it's whatever string we want it to be. So let's do height versus age, and we'll do an x label, plt.x label of age in years, and we'll do a y label of the height, which is in inches. Okay, and now if we run that, then we see basically the same plot as over in the other picture, but without the other complicated stuff. So we have height versus age, we have the age on the x-axis, and we have the height in inches on the y-axis. We can clearly see that there's a linear relationship here. Linear meaning we can draw a line through this data, and that line is our model. Okay, that is our main goal, is to produce that line. So now that we've visualized this data, really the best that we can for now. There is, of course, more complicated methods to see various things, but this is actually pretty good for now. It's probably all I would do either. I would now jump straight ahead into building the model, and then of course after training that, but first we have to define the model. Now, by model, we mean what are we assuming the relationship is, okay? So we're assuming that the relationship is basically y is equal to some parameter, because we need some intercept here and then a line. Okay, so a line has two parameters. It's the intercept, which is a constant here, and then it's basically its other parameter is the what to multiply by the input. Okay, so that represents basically the angle, okay? Angle, or really the slope of the line. So how quickly the y, or the height, is increasing as you increase the age. Okay, so two parameters. You can bump it up like a constant here, and you can tilt it any which way of this line. So we're assuming that y is equal to, let's call it alpha, and then we're going to add some other parameter, beta. So these are our two parameters, alpha and beta, and then we'll multiply that by the input. Okay, this is really what we're saying the relationship is, except is that true? I can tell you right now that that's not true, because look at it. That would mean that the data fell perfectly into a line. If this was actually true, all of our data would be perfectly in a line, but it's not. So what is instead true is we write plus this epsilon. Okay, and the epsilon is what we call the noise. Okay, so if we imagine some line here, then that part is, you know, our best guess at what the data is going to be. If given an age, we'll make our guess to be whatever that point in the line is, except we know that overall it's not going to be true that it's exactly equal to that. And so we define this epsilon thing saying there's noise, okay? It's not going to be exactly right. But overall, we assume that this epsilon is on average 0. If it's on average 0, then when we're actually going to make a best guess, we're not going to include the epsilon in the model, okay? So technically we're saying if we're treating these as true results, then yes, y is going to be equal to some line, this is the line part, plus some noise. Okay, that's definitely true. Except if this, on average, this noise cancels out to 0, then there's no point of including it in our best guess, okay? So really what we're going to say is if y is this, then y hat, which is our best guess, is alpha plus beta times x. In other words, just our line. Okay, that's the definition of a line. And it's parameterized by these two things, two parameters, alpha and beta, which we have to learn. All right, so we have to learn which is the best spot to put the alpha up here, and which is the best angle or slope to learn the beta. All right, so before we get to actually learning that thing, and I'm not going to run this code, really that should be in text because it's just explaining something, but I'll just leave it there, that's fine. And so to define a function in Python that we can use for our model, what it does is, and DAF is just, it's making a function, we're going to define y hat, so this is our best guess, given an x, okay, so given an input, or we could even write given an age, and it's given our parameters, which I'm going to call params. So it's given our parameters as well, which I'm going to make a dictionary. So actually I'll put this in a cell above. And so first off, what are our parameters? They're going to be alpha. Okay, and sorry, if you don't know what a dictionary is, I'll just show one very quickly. We have D is equal to, say, A, comma, 5, and B, comma, 7. Okay, so comma, sorry, this should be colon. It's comma separated key value pairs. Okay, and we separate the key and the value by a colon. So this is saying we have two key value pairs. We have A, which is 5, and B, which is 7. And we could access either of these very quickly, given maybe we wanted to know what's in A, we could do this, okay? And if we did D sub B, it would be 5. So I'm going to store my parameters in one of those, and we can get alpha. Well, okay, what is alpha originally? Let's just say it's, I don't know, 40. Okay, so if it's 40, then it would mean it's this value. We'd start here. Let's start here. And then maybe we'll start at a slope of maybe 4. Okay, so maybe these were our initial parameters. We just chose them kind of randomly. It's obviously wrong. Okay, I'm just choosing them because, you know, we don't know what the right ones are. And of course I could eyeball it for you. I could write 25 and I don't know, 2 or whatever that is. But the whole point is we want our model to figure that out. In most scenarios, we're not going to be able to just eyeball it, and you know, it's not the right thing you want to do. So right now they're randomized, and we want to write this function, which given parameters and an age, it's going to return our best guess. Okay, and our best guess is right here. All right, I'll just copy that. Alpha plus beta times x. So we want to return that, except this x is really the age here, it's this thing, and the alpha and the beta, that comes from the parameters. It's for these given parameters. And so we'd have alpha is equal to params sub alpha, and beta is equal to params sub beta. All right, so let's just test this thing out. If we gave it these parameters, which are right here, if we had maybe y hat of an age of 5 and our parameters that we have up there, what does it produce? It produces 60. Does that make sense? If we have an age of 5 and we have an alpha of 40 and a beta of 4, well, it's going to be something up like here. And so yes, that actually makes sense if we had an age of 5 would be something like that. Okay, so that looks like that function works. This is basically our model's best guess. Okay, so given our age and parameters, we can get a best guess. Now what we want to do is learn the actual parameters. Okay, so we don't just want to guess these things or keep them randomized. We want to learn these parameters. We want to learn the right alpha and the right beta so that we put the alpha here, the beta here, and it makes the right line. Okay, and now the right line, quote right line, is up to some metric, and I'm not going to worry too much about what we're trying to minimize exactly, but the point is that we're trying to keep the points as close to the line as we can, really. That's the main thing, is that we're trying to put the line in the basically somewhere in the middle of the points so that we are close to as many points as possible. And to do that mathematically, we end up minimizing some function with respect to this alpha and the beta. Okay, remember we're trying to find the alpha and beta that best really minimizes some function of saying I want the points to be really close to this line. Okay, in next tutorial or next lecture I'll go over more mathematically about what that actually is, but for this one it's not too big a deal. We're trying to keep the points close to the line, and by doing that we're trying to learn the parameters. And if it sounds like I'm really killing this point, I'm sure I've said it too many times, but that's what we're going to call supervised learning is all about. And that's the main chunk of machine learning, is all of these cool applications like image classification. It's all doing the same thing with deep neural networks. It's just learning these parameter values, okay? And we're going to build up to that at some point, I promise. But this is the first step. We're trying to learn these parameters. That's all that a neural network does too, except neural networks learn many, many more parameters. And the function, this best guess, is much, much more complicated than alpha plus beta times the input. Okay, so sorry if I'm killing that point, but it's because it's extremely important to all of machine learning. Okay, at least all of supervised learning, which is most of the cool applications nowadays. Okay, now with that being said, if we're trying to learn these parameters, well, it's not so easy. It's not so easy to explain. Mathematically, it's actually very, very easy. And I'm not going to bore you with that, at least not yet. In the next lecture, I'm going to bore you with that, as in explain what's actually going on. But for this one, I want to keep it simple and just say I'm going to write a function that will learn these proper parameters. Okay, it's going to find the ones for you that do this. Okay, and the one thing I'm going to point out before I do that is that in this statistics method, so we're using simple linear regression, and so we're just drawing a line. There is an exact solution for that, which I'm going to write and I'll talk about next time. But in neural networks and other more complicated stuff, we don't solve it exactly. We do a bunch of mini updates to get to the best thing, to get to the proper, or at least a good choice of, say, alpha, beta, or whatever parameters you're learning. Okay, so with that being said, I'm going to write this function that just kind of learns the parameters. Sorry for that very awkward transition where this function appeared out of nowhere, but I didn't really want to show you the process of building it. I don't think it's too important right now. So we define learn parameters whose job is to take in data, which we're going to pass it this cleaned data, okay, the AJ and the height columns. We're going to pass it that, as well as whatever parameters, and they can just be like a dummy dictionary where, say that we have something like these wrong parameters, it's going to manipulate this variable that we pass in so that the alpha is the correct alpha and the beta is the correct beta, according to minimizing this distance thing. Okay, so it's going to produce an alpha that's probably around 25. You can eyeball it, and this beta that I don't know is maybe like 2 or something like that. I'm not quite sure yet. Okay, so let's actually run this function and see what happens. So I want to actually hold on to our old parameters. So I'm going to make new parameters. So new parameters is equal to, say, alpha with 0 and beta with 0. Okay, so if I have this new dictionary, and then I'll learn the parameters I'll pass in the cleaned data, and I'll pass in the new parameters. New parameters. If I pass in that, then what it should do is output the right parameters. Okay, so here we have an alpha of 30. All right, so we knew it'd be somewhere over here. It's going to be an alpha there, and a beta of 2. Okay, I was right about that. It goes up by a slope of 2. Okay, now before we show this information, okay, we showed that these are the correct values. Let me show you first just our old parameters, how they would have been plotted on the graph, okay? So first, if I copy almost all of the information from our plotting function, okay, so we plot this information. Again, this is the same graph as before, but to produce, I'll just show you how to make a line given some function, and first I'll do it on the old data, or on the old parameters. We need a bunch of x values that are in this range, so that then we can make a prediction point y. So given that x, we'd produce this y for the parameters that we have, and then if we have a bunch of these points, say if we space this out, we could predict all of these values, and then we could draw a line through those points. Okay, so for our wrong parameters, which we're going to do first, we're going to have these x values, and then it's going to have, according to our parameters, it's going to make a function that looks something like this. If we look at our alpha and beta here, it's 40 and 4. So first we want to draw this wrong thing given our first parameters. So it's going to draw like this. So the first thing we do is make this thing a bunch of x values, which are spaced across. So I'm going to say spaced ages is equal to, I'll turn this thing into a list. Don't worry about this too much. It's basically just saying this range object up until 18. So this range, I'm going to put it till 0 until 18. It's probably not inclusive, so it's going 0 to 17. And turning it into a list will produce this thing. Okay, so now that we have this, we can actually get a bunch of predictions given our whatever parameters we're using the function that we built. Okay, so we have this prediction function which takes in some point and whatever parameters we're using to define the model, and after that we can call that several times for each of these x values that we produce in the range of 0 to 17, and then it should produce the corresponding, basically a bunch of points, but I'll write the function or write the graphing in a way so that it produces a line instead. Okay, so if we have, sorry about the jumping around, we have spaced ages is the stuff, and then we basically want another list which is the corresponding outputs. Okay, so if we say spaced untrained, so with our bad parameters, spaced untrained predictions, if this thing is equal to, we could do a cool notation, which actually I'll show very quickly over here. We can make a list object in Python very quickly by doing, so say for example x for x in range 10, what that does is produces this list of 10. Okay, and I could have done something similar to build this spaced ages as well, but here we're really going to need it, where instead of this thing, we can write for each of the objects in the spaced ages, because we want the predictions for these x values, then we want, I'll write for now x, and that'll make sense shortly, x, but y hat of x, and it says for age and params, so here's our age, that's going to be each of our ages, and then the parameters that we want, which parameters do we want, we're calling it parameters, is our untrained one. Okay? So for parameters, or our untrained ones, we want y hat of x and parameters for each of the x in spaced ages. Okay, and so what that would produce is the output for each of those spaced ages, or sorry, this thing, and that is our corresponding output that we want. Okay, so we can now add this to our plot of information. We can do this as follows. With scatter, we're putting the blue raw data on here, except now we could just add another one here where we do plt dot, and I don't want a scatter plot. What I can do is actually just call plot. This is going to produce a line, Okay, it says right here, plot y versus x lines. And so if we plot the spaced ages and the spaced untrained predictions, now we need to give this thing a label, and we'll let it equal the, basically we'll just say untrained predictions. Okay, we could have actually said the alpha and beta that correspond to that, but I'll just say the untrained predictions there. Okay, and now by default it's actually going to give the same color, but we can define a color very easily and say color is equal to, say, green. Okay, so now we have this line that produces this thing. All right, so for our untrained predictions, we have this bad line. Now, of course, we don't want that. I was just illustrating that, we can do this. But the point of why we want this is to have it for the actual line, okay, the good line. So we first need to train our parameters. Okay, so we did that. We did new parameters as these dummy values, and then we called learn parameters, and it showed that these are our best ones. So we can call this again with the trained ones. Okay, and I'm going to keep this plot just for fun, and I'll copy everything over. Okay, sorry, this should actually be above here. Okay, so if I copy all of this stuff, but now I again basically do the same thing, but I'm going to plot not the spaced untrained predictions, but the spaced trained predictions, which we also have to get. And so I can copy this as well. It's going to be the same thing as what we did before, except we need different parameters. Okay, so these things, these spaced trained parameters, spaced trained predictions, these are going to be the same things as before. We can use the same x values, and if you're confused why we needed so many x values, technically we could have just done 2 x values because it's producing a line between it anyway, but I showed you that we're going to kind of space it out for fun. And now the spaced trained predictions is going to be the same thing as it was before with the other parameters, except with the proper parameters, which we learned. Okay, we trained our model on the training data, and we got these new parameters, and we're calling that new parameters. Okay, and now so we have that information there. We plot it as spaced trained predictions. We give a color. We'll say that's equal to not blue, orange. Okay, there we go. So we have a line through the data. You can see it worked quite well. We can actually add one thing here just to make it look a little bit better, is we can do line width is equal to 3. All right, that's good. And actually, just to be consistent with the other graph from what I showed you before, technically I had these values, these colors reversed. So really we would have this, and notice our legend is going to go along with it, so it doesn't matter. So we have our untrained predictions like that. Our trained predictions with the learned parameters goes right through it, and it goes right through our raw data, which you all have plotted here. All right, so we trained our model. It's great. That's the main point of supervised learning and most of machine learning, is to make these functions so that we can make predictions on unseen data. Okay, so yes, we trained our model, except the point of using it, and I can erase this dictionary stuff. The point is to use it on unseen data. So maybe we've trained this model on this data, but now in the real world we go into production, and for some reason we want this model that we don't know the height of these things. We want to approximate it by just given the age. So we do know the age. Maybe a new age is equal to 5. Okay, so we want to be able to ask this thing, hey, what is the height? Because we don't know. We were training it before because we had values where we did know the height given the age, and so we're going to make an approximate function for that. Except now we don't know in the real world. So the point is to use our model, and again, we still have our same function. We're calling it y hat. Okay, so I can just copy that here. If we have a new age of 5, then if we call y hat on new age and our new params, remember these are the learned parameters. I forget if it's new parameters or new params. On new parameters, okay, So what that produces is say 40, okay? And is that actually what our line shows? It better be 5, and we have 40. Okay, so this, although it's this 2 seconds, this part is super important because we train the model now on real world data. We're going to use it because we don't know the output, but we do know the input. And so we're going to use the function that we learned to take a best guess at it. If you're listening to this, you're going to want to do, again, a couple of things I said at the beginning if you hadn't already. One, you're going to want to subscribe to the channel and ring the notification bell so that you know when I get a video out and you know when I get this next video out, because knowing this is great, it's extremely important, but there's a couple very important things that I did not want to talk about in the first video, such as training this model. Okay, we have so much to learn for this learning thing. We kind of just skipped over it completely, aside from saying we're learning. Okay, so that's super important, just to learn how to do that, because that's the main part of machine learning, is how to train models. Also, we kind of skipped over this whole testing thing. Okay, so we didn't really talk about testing our model, where yes, we were predicting a new age, or given a new age, we're predicting a new height, except we didn't really talk about how well it's doing. Okay, we just said it's trying to minimize the distance on the training set, and that it's able to predict these new things, but we didn't talk about how good it was. Okay, so there's a couple things we're really missing, and along the journey I'm going to make it just as easy as this one hopefully was. If you liked the video, please give it a thumbs up, and please subscribe to the channel and ring the notification bell so you know when the next one comes out. Alright, have a great day. Thank you. Bye-bye.